All right. So now let's start from beginning to in order to review what's happening in 2022. I want to go back to the beginning of what we call the major event, that is the transformer, because everything happening, the whole revolution that's happening with ChatGPT starts with transformer. Of course, the transformer, if we go back a little bit, it will be starting from 2012, the actual deep learning become mature. But for our purpose, the major event is the transformer. So everyone knows that the transformer started in 2017. And with that, the GPT started 1 year later. And the GPT is the first first model that use transformer to train on a large collection of text and doing unsupervised learning to improve the transformer model to understand the natural language. So that's the first model. So as you can see the timeline, after GPT, we have a BERT happening a few months after GPT. But the BERT is the first one that actually surpassed human performance in terms of question answering. So that was very exciting. People started to realize there's so much power. Now the NLP is very powerful. So continue from there, the next 2 years, 2019 and 2020, we have GPT-2, which is now 10 times or 15 times larger than GPT. And then 1 year later, GPT-3 is 175 billion, which is how many times? Which is, I would say, 25 times. Yeah, 25 times larger than GPT-2. So by 2020, about 2 years ago, GPT-3 has demonstrated that it is very powerful. It can do a lot of things. And so and then the field, the AI field for the next 2 years from after the GPT-3 was released, continuing to develop. And then that reached the highlight is the ChatGPT. So then we will look at what has happened since then. So what has happened is there are two things happening. So here I want to step back because in order to summarize the major breakthrough in 2022, there are two threads. One is ChatGPT, which is pure text-based. Another is diffusion, the text-to-image generation, which is the breakthrough of computer vision combined with NLP. So in the second thread, in the image generation, what we see between 2020 and 2021 the transformer started to apply to the vision model. So before end of 2020, all of the development is on the natural language side. But then people realized we can actually use the same model to model image, computer image. So try to explain a little bit how we go about modeling an image in terms of tokens similar as a text. This is a very quick introduction so that we establish the context. So we know text are tokens, the image also can be decomposed into tokens where we take a patch from the image. And then the second breakthrough, so if you see, once we are able to decompose the image into a token, we can also do some video modeling. So not only image, video is a sequence of frames. So we can also do videos. Then we have a video transformer. And from there, we can also combine text and image in one transformer. So here, another major breakthrough in so let's go back to the timeline. This is 2021, still not 2020, but this is a foundation for our breakthrough in 2022. And the two major events happening in 2021 is the CLIP. CLIP is both are from OpenAI. Clip and DALL-E are both from OpenAI. So what is Clip? Clip is the first model that combines image and text. So they were able to take all the images from internet with captions. So since their caption is coming together with the image, we know that they are connected. They are somehow should match each other. And from there, they generate tokens of the same size from the image and from the text. Then they automatically match those tokens by using unsupervised learning called contrastive learning. And using this method, now once you finish this training, we have, okay, I'm going to disable chat for now. There's another bombing happening again. Okay, so for the clips, this gives us a very powerful way to combine the image and the text. So this is the first breakthrough. And the second one is DALL-E. This is happening also in 2021, not in 2022. So in 2021, in OpenAI, based on Clip, they were able to do this is the first text-to-image generation work, where you give a sentence, and then you can generate the text from, and you can see, you can also change some words in the sentence by saying now we can do a painting, we can do we can do a more less style, we can do different style, but doing the same thing. So with this, this is a very exciting work, but it's not based on diffusion model at that time in early 2021. It's based on so-called variational autoencoder, which is kind of part of diffusion model today. It's a kind of a foundation, but it's not as easy as computational efficient. So this is the what's happening in the 2021 now. The diffusion model, I want to also give a review, just a quick historical highlight of diffusion model, because by 2022, diffusion model become mature. But the history of diffusion model is very early. It's very recent. It's only in the middle of 2020, the first diffusion model, which is the one used, people reference 2015, but the actual diffusion model people use today is invented in 2020, called the noising diffusion probabilistic model. And so it's an unconditional, when we say unconditional, basically it's not, it's basically take just pure generation of text, take a random noise picture, generate an actual photo, right? So it's, and when we say conditioned or guided diffusion by 2021, it's now we can introduce additional requirement, like this picture should be based on certain kind of guidance, certain kind of text. So I want to generate a picture of a rabbit, a picture of a dog. So once I give a guidance, the picture will generate conditional, not on my words, and not only on my words, but also on the original, the random picture. So that is called the guided diffusion. So guided diffusion is also called a classifier-free diffusion guidance in its full name. The name for that is because before that, people use classifier-based guidance, where suppose you know the class, suppose you have 1,000 what categories, then you can generate, because we learn through image data, we know certain categories dog, certain categories cat. So we have a certain classifier already trained. And that allows us to generate some targeted picture. However, in many situations, we don't have a classifier. So the classifier-free diffusion guidance become much more widely used today because it's much more flexible. And then another thing happening by end of 2021 is called the latent diffusion model. It's also called the stable diffusion model. And that is the one that's the one actually used widely today in 2022. But it's the condition, it's based on the previous two models. So today you will see the reference for both classifier-free diffusion guidance and the latent diffusion model. So all of this happening in 2021, right? So we haven't reached 2022 yet. Now, for those of you who are new to diffusion model, I want to give a very quick high-level summary, which we talk about in our meetup for many times. But for those of you who are new tonight, and maybe you already look up or learn some diffusion model, but this is a very quick highlight. So when we do diffusion model, essentially we are trying to learn the probability, conditional probability P, based on what we observe in our image data. So in our image data, we know that given any picture x0, if each time we introduce some noise, we eventually will end up, by time t, we'll end up with just a random picture. And if we can recover this probability in the reverse order, like p, and P is conditional on theta. Theta is our neural network. So we use a neural network to learn about this reverse probability. And that's the whole thing about learning about the diffusion model. So this is the basic idea. And so-called text condition, the diffusion model is introducing one more parameter into this model where not only you generate an image, but it's conditional on the text you send into this probability. So you have two variables that you conditional on. And the first model that's actually making it practical is also from OpenAI. It's called Glide. And this model, invented by end of 2021, becomes the foundation for DALL-E 2. That's the one we see in 2022. So this is a summary about the three models. Another thing also happening in 2021 becomes very important for ChatGPT is introduction of reinforcement learning with human feedback. And this methodology was invented in 2021 for text summarization. At that time, it's also from OpenAI. So at that time, they want to improve the ability of we summarize articles or summarize a book. But we don't want to retrain the model each time. We don't want to send a lot of training data and then fine-tune the model. So the way we quickly do the training is use a human to give feedback to the model, and using the so-called reinforcement learning. So this is just an introduction of before 2021, before 2022. So now let's look at today's topic, AI in 2022. So first thing we know that first we have a huge advancement in image generation with diffusion model. So we know diffusion model by end of 2021, all the mature method has been invented, and then there are Glide that's starting to use text conditional diffusion model to generate image. So that's end of 2021. And 2022, we see this explosion of text generation, text to image generation. The second one is ChatGPT and all the advancement happening with ChatGPT. The third is, I want to mention this so-called generalist agent, where now we have a unified model to handle many different input modality. One model can handle image, text, speech, and other, and even robotic input. we don't have to have a different model, different learning happening. It's all happening inside one model. So this is very powerful. As you can imagine, in the future, we will have one robot that interact with human doing many things. And thirdly, is Whisper. We know Whisper is a huge advancement in terms of the accuracy of speech recognition. And also mainly all the advancement, particularly with ChatGPT, is helped by this reinforcement learning for large language model. So so first, let me let's take a quick look. Sorry, I have to remove the text. I think it's confusing here. This is for sorry, the top text is for 2021, but let's take a look at the advancement in 2022. This is one thread. This is for the ChatGPT thread. So in the ChatGPT thread from January to December, in January we have Instructor GPT. Instructor GPT is introducing using reinforcement learning with human feedback to improve GPT. Now we have a major advancement in GPT. And then PaLM is from Google with pathway. It's called a pathway language model with 540 billion parameters. And it's an attempt, because we know that the larger the model, the more powerful it is. So Google is trying to push the envelope to see how far we can go. And so this is the attempt of PaLM. And certainly PaLM is better than GPT-3, but the PaLM itself is not trained with reinforcement learning. So in reality, its performance is not as good as Instructor GPT, or what we call GPT 3.5. And then in August, Facebook released the BlenderBot 3, which is a big advancement in chatbot. And we talk about in this meetup about BlenderBot 3. And after that, DeepMind by end of September released the Sparrow. Sparrow now is similar to Instructor GPT. It uses reinforcement learning, but try to use that to improve the dialogue system. And it found a major enhancement, major jump in terms of accuracy and user satisfaction. And finally, by end of November last year, just a month ago, OpenAI released the ChatGPT. So this is a thread happening. In another thread, I will mention at the end of the talk today is COT, chain of thoughts. And the chain of thoughts, SC means self-consistency. So chain of thought and the chain of thought self-consistency are trying to use prompt engineering. So what people realize is now if you have a ChatGPT to make, or if you have a general GPT API, to make it work for you is to create some smart prompt. And so people start from January 2022, last year, people start to realize if I can make my prompt more intelligent, then I could get the outcome better. So actually, let me talk about the chain of thoughts first, even though I put that in the later slide. Let me. Okay, so in order to explain chain of thoughts, for example, if you want to build a good system based on ChatGPT, you give some intelligent prompt. So chain of thought is a very smart prompt. A prompt basically is some example you give to GPT or ChatGPT. So they gave a very interesting, the way they gave example is if I'm trying to solve some mathematical problem, Instead of on the left, you give an answer, question and answer, and then you expect the system give you the right answer. It doesn't happen that way. So what happens is you engineer your prompt. You inside your prompt, you give some reasoning of why you arrive that answer. So then the system somehow will learn from this prompt. It does its own reasoning, and once it's doing the reasoning, the answer will be correct. So this is like magic, right? So, but this is what people discovered, where when you do prompt engineering, you can actually improve the result. And so chain of thoughts, it's a very powerful way to make the computer, the system, to think through on how it arrived the answer. And so 2 months later, in March, this is all from Google. So the Google researcher realized they can improve the chain of the prompt engineering a little even more. So the way they improve that is they introduce several parallel reasoning. So here, before you have before you have one way to reason and you arrive at the right answer. But now you can give several reasoning, different way to reason. The one arrive at the right answer, another didn't arrive at the right answer. So using that, you can allow the agent to have multiple reasoning paths. So this is a so-called self-consistency. Anyway, so let me go back to our summary. Okay, so this is the thread for ChatGPT. Now, the second thread, I also want to remove this highlight here. Sorry. So the second thread, if you look at what I mentioned, is it's a so-called generalist agent, where we combine multiple input to make the agent more intelligent. So what I meant by that is, in January, Facebook released the data to WAC. And so this is the first time where we see that because before that, in 2021, we now know we have a vision transformer. The transformer can handle image, video, can handle speech, can handle text, but people have not combined them. So in January 2022, last year, people started to combine each of these, saying we can use a similar one type of model. Even in this paper, they didn't use one single model, they used 3 different models, but it's the same architecture. So basically the research, the breakthrough is we can use identical architecture, identical number of layers, and then identical training method. So the way they train this model is using so-called self-supervised learning. Self-supervised learning, where you basically means you don't have labeled data from human. You basically take a collection of text to train a language model. You take a collection of speech to train a speech model. There's no human to do labels. So the way they do self-training, the self-supervised training, is mask a certain component, certain words in the text, or mask a certain segment in the speech, or mask a certain part of the image, a patch in the image. However, what they showed that is you can use identical training method to train a transformer and to achieve very good performance relative to a traditional text model, traditional speech model, and the traditional image model. So this is basically the attempt for us to see that one transform model can do many different things, right? So this is the kind of very exciting work. But the real breakthrough, what I see as a breakthrough, come from DeepMind, the so-called generalist agent. I think there should be a lot of follow-up work for this, because this is what I see as what we call AGI, the artificial general intelligence, because this is the first time we see a very practical agent called a Gato. It can receive all different it can use one single model doing many different things. So it takes the image input, can generate image caption. So it takes the image, generate a text. It can play games. It's basically the way it play games is look at the video or image frame, and then decide what to do, how to play the game. It can take on the lower left, the robotic arm, basically looking at what's on the table and decide what to do, how to pick up the block. And it can also do dialogue, like on the right, takes text input, do the text outputs, and also do a very consistent dialogue. So this is what we call generalist agent. Now, how does the field arrive at achieving a generalist agent? And what we see is the way we can achieve this is by having a representation. We should be able to represent everything inside our model. Our model is a transformer. And for transformer, the input is a sequence of tokens. So for text, it's a sequence of words or subwords. For image, each patch was converted to tokens. How do we represent a game, a computer game, right? So here is their innovation here. So if we are playing a computer game, what we have is so-called observation, which is you can think about observation is the image, the actual image frame, and then the action. So if the agent can take maybe 4 different actions, each action will be represented as a token. So we can actually have a token represented playing up, down, left, and right. And those tokens will be our vocabulary. So what they did is introduce additional tokens as our action into our vocabulary. And the image themselves also formulate as tokens. So now we have the image token plus our action token. Combined together, we have and also we have some history observation, right? What agent did before based on those images. So those are our prompt. A prompt is example showing what the agent should do. So if the ball comes, or if the enemy shoot at me, I should shoot back. So those are the basic examples of what I should do in a certain environment. So you send that prompt together with the actual frame, so the actual situation the agent face, then what the agent respond. And once you send that, and then our model, which is a generative model, so we will continue to generate additional tokens. All the new tokens generated will be either action or what we are observing next. So if your intent is to generate action, you can specify that to be the action token. So that is how we represent how an agent playing games or how a robot doing certain things. Combining with all of that, we can train a generalist agent like a Gato by sending all this training data. So the training data is either a game sequence. The sequence is a mix of the frames, action frames, the next action. So you send this sequence of gameplay, or you send a sequence of like a dialogue. Those are also your what the agent does in responding to certain conversation. Or you send the image description and then the robot action. So as you can see, everything in this world, every action we face, it can be essentially represented as a sequence of tokens, which is very remarkable, right? Before, we certainly before transformer, we know that we can, computer is able to represent the image in terms of pixels, represent speech in terms of the segment of like transformation, the Fourier transformation of the speech segment. But we can represent the word in terms of the token, the word embedding. But we have not unified them until last year. Because only until 2022 we now realize image, speech, text can all be represented in the same kind of format. So we don't need to represent the image as a pixel. Instead, we convert them into also tokens. And what is token? A token essentially, what we call embedding is a vector of numbers. So if I wanted my embedding or then vector to be 100 dimension, we would say every image token will be converted to a vector of 100 elements. And the same thing for text, same thing for speech. So now they all represent in the same size of vector. Then we can do a lot of things to get with them, right? We can then match them. We can say this word match to this image. We can say this action match to this picture. So by representing them in the same kind of embedding space, the same size of vector, now we can do this uniform processing computing. And in addition to that, we can train an agent to simultaneously learn about this multiple modality at the same time. So as you can see here, for this model, a gato basically is a transformer, is a deep neural network, right? So this whole thing in the middle, gato, is a deep neural network. The input to this deep neural network is 4 training data set. So here, the example here is we have 4 training data set. Each is a different task. And each task is represented by a sequence of tokens. And the output for every task, my output is also a sequence of tokens. So now everything, this is why where AGI potentially can be achieved, is now everything input, output is all the same. It's like in the early days, the computer we represented inside the computer program, everything is 0 and 1, right? So whether it's image, whether it's instruction, comes down to 0 and 1. So here is the same idea, but it's in a more high level, more condensed level in terms of number of vectors. So this is what I feel very excited that what we can achieve now. And this, in the same year, after generalist agent was basically done by DeepMind. After that, Pauli is the one. It's a model from Google. Certainly, this is a very like smaller version than generalist agent, but it's still very interesting. What they did is they showed that you don't have to retrain the image, the original transformer model. If you already have a big text-based transformer like a POM is 540 billion parameters, so they don't want to retrain POM just for image. What they did is they have a separate transformer called the VIT, the vision transformer. So they send the image to vision transformer, then send it to POM. And the POM receive the text from outside. Then they concatenate inside this architecture called the Pauli. And then you can get the answer. So basically, this is a visual question answering. I look at the picture and I ask what type of flower is this, right? And the answer is a sunflower. So this is a more smaller version of what we call unifying the architecture. All right. So I talk about the second thread where we have, sorry, I think I didn't delete enough. So the second thread is a generalist agent. The first thread is chatGPT with reinforcement learning. The third thread at the top, sorry, okay. The third thread at the top is the image generation. So I mentioned that before end of 2021, all the diffusion model is already being invented and it's useful. So by 2022, the major development is the image generation, text to image generation. So first is DALL-E from OpenAI. And the DALL-E, we mentioned that there is a glide using the classifier-free diffusion guidance from text to generate image. So they trained a glide. Combine glide with clip, which we mentioned is clip use contrastive learning to learn about the mapping between text and image. So using that mapping, they learned between text and image combined with glide, which is trained on generating an image based on text. So it's a generation model. Glide is generation model. Clip is a embedding mapping model. So give you the right way to map certain kind of image to certain kind of text. So combining these two, they were able to create a DALL-E 2. And DALL-E 2 is it's very impressive, right? So it showed much better performance than DALL-E, which is not a diffusion model. So DALL-E 2 is the first diffusion model, which been actually applied to very successfully generate text to image. 1 month later, from this is so DALL-E 2 is from OpenAI. From Google, they created the Imagen. Imagen is going beyond this DALL-E, just generate the image. They want to generate a high resolution photorealistic image. And to do that, they used a trick called the super resolution. So after they generate a 64 by 64 image, they went through two more like upsampling, where you convert a 64 by 64 to 256 by 256. Then in addition, after that, do another super resolution. Now you achieve the 1024 times 1024. So these two super resolution steps give us the actual high resolution image. Before that is the very similar to DALL-E. Before that, they do the text to image diffusion model. In the late 2022, we have many because now this actually is around May. Imagen was around May. After that, everyone got very excited. So there are a lot of additional development on how we can manipulate, how we can actually use text to quickly change the image. And one of the development is Imagic. Imagic is very interesting. You can actually very specifically modify the image simply by saying it's the same image, a bird, but now make the bird open up the wing and make a person have a different gesture from the same picture. And the way they achieve, so I want to just quickly talk about how we build the Imagic, how Imagic build this. So the actual step is 3 steps. The first, they are trying to optimize the text embedding. So if I give instructions, say a bird spread the wing, how do I know I'm talking about this particular bird, right? So before that, they have to basically map certain words to image. So the text itself should represent certain things. once I say certain text, I should generate a certain image. So this is text embedding. And then the second step is so-called the model fine-tuning on the diffusion model. Is how we generate an image based on a diffusion model. And the third is we take the original text for that picture and our target text. So original text is just a bird, and target text is a bird spreading the wing, and interpolate those two that give us the new image. So this is the steps to generate. So one more thing is this is the image text to image generation, and there are many additional development I'm not touching here. One is so-called image editor. So now you can have very interesting editors where you can specify, say, change the. So if I have someone sitting on the sofa, you can say maybe standing on the sofa, change certain words, and then the picture will change. So that there are several applications out there to give people a way to edit their image based on text instruction. And so those you can take a look at the link on Imagen/editor, imagen.research.google, image.research.google.com/editor. That'll give you the newest editing capability for Imagen. Okay, but now I want to move to a new dimension where, which is I think very exciting, is the video diffusion model. Because from text to image, the next step, natural step, is to give people a way to generate a video. So how do we construct a video from text? You can think about video itself. Essentially, it's a sequence of picture frames. So basically, what we want to do is we take this will give you an example. If we take a input text. So for example, this is a person doing yoga outdoor during a sunrise. So this is a picture. This is a text. For text to picture, we can generate a picture from there, but we would like to generate a sequence of pictures that become a video. So the way we can generate a video, the methodology here is this is basically a 4D model where you added one more dimension, is the time dimension, not how many frames I want to generate. And the way you generate the frames, in here you can you have probably the model itself has some spatial temporal model that pre-trained based on certain videos. So it carries certain kind of understanding about the spatial temporal movement, and then you can do interpolation on that, and then finally generate a video. This is a very high level summary. And so if you want more examples, there are two major papers on text to video. One is called Finaki, another is Imagen/video. Both from the same group. The second one is from the same group as Imagen group. And so this is just one example from Finaki, where you give an image, you give a text, then they generate a sequence of frames. The frame will show you what the cat is doing, right? So that if you run them together, it becomes a video. Okay, I'm trying to run through the time. Now, finally, I want to talk about how the reinforcement learning is actually used to improve GPT, because this is part of the ChatGPT magic. We know that ChatGPT has two major functions. One is NLP. It can write a poem, can write anything, right? It can summarize, it can do a chat. So those part, what we feel it's very easy to understand, because maybe it's because our Meetup or in several years work in previous talk, we have went into depth of how each of these NLP tasks was accomplished. The second part for ChatGPT is doing the coding, it generates the code for you. So what's behind the ChatGPT is two components. One is the GPT-3 trained on a lot of text collection. The second is a collection of all the code on GitHub. So once you have the code on GitHub, you can then basically predict what will be the next token, right? So you can treat all the Python symbols as a token. And basically it's similar as learning natural language. You are learning the token generation. It's the same methodology, but a different training data set. So I'm just skipping through. If you are interested, you can read their paper, OpenAI's paper called the Codex. Codex was released in 2021, not 2022, but it's very useful and still later become a product. So Codex released in 2021. In 2022, it became a product called Copilot. And in the same year, DeepMind released their alpha code in February. And then later this year, by December, DeepMind refined the alpha code. So you can also, so both are competing. They're doing the similar thing. So Copilot and AlphaCode both are able to give you very good like a code generation capability. So now the ChatGPT incorporated the Copilot into ChatGPT generation. So now given the time constraint, I want to just mention how the instruction GPT how it improved the performance. So the way we improve the performance of of GPT is basically we let our model to generate a certain output, right? So if you say create a summary of this article, so the model generates several summary. Then we let a human to evaluate how good this is. The evaluation was done through comparison. So basically, to simplify this kind of training, we basically let two humans, we generated two summary, and then let a human just tell us which one is better. So this is a very simple, simplified, and faster way to do evaluation. If a human say A is better than B, then the reward for A will be positive, right? So that's what we call reward. After the reward, then we can send this reward back to the original model. Original model we call PPO. It's a reinforcement learning model. So the idea is this is a high-level understanding about how reinforcement learning is used. So the reinforcement learning essentially take an input, generate action or output. The input here is the original article. The state is the article. The output is a summary. So all the tokens is generated. It's the sequence of tokens is action. So we are learning what is the best sequence of tokens we should generate. If we got a positive reward, our current system will be, all the parameter will be updated. So we will update the parameter using the loss function in this reinforcement learning methodology. So our language generation model become better because next time our sequence token will give us a better reward. So this is the way we improve the current language model without having to having new training data set, right? So we don't have to do fine tuning. We simply use the reward from the humans to update the model. So this is a high-level summary about how to use reinforcement learning. And this model is very powerful, as when people showed that with instructed GPT, even with a very small model, 6 billion model, it's already better than the 175 billion original GPT-3. So the vertical is the human, like the score of the human, how human like the model. So this is why ChatGPT has a huge advantage over almost all the other models, even all the Google's big model, Palm 540 billion model, because you don't need such a large model. You can have a very small, like 6 billion model, still have very reasonable response, reasonable output to the user. So this is what is very exciting. So I want to quickly summarize. Now I will open up to discussion. For the 2023, so Sparrow, I mentioned the Sparrow is also using the reinforcement learning to improve dialogue, and they are going to release their model in February. So we are going to see this instruction-based using reinforcement learning to improve the model continue to come in 2023. This is the first thing I predict for this coming year is since most company won't have the power, the money, and also the time to train their own model. They will use, so if you build anything, the way to improve is better use a reinforcement learning method to keep improving your model. Secondly is people have tried, like actually have a I don't have time to show today, but a most recent paper from Facebook showed that they are trying to train a competitor of GPT-3, so called OPT, or Open Pre-trained Model. So OPT, that's in Hugging Face. OPT didn't perform as well as GPT-3, so they try to improve with reinforcement learning. After that, they achieved a little bit better performance, but it's still worse than instructed GPT. So it could be the way they do human evaluation is not as in-depth as what OpenAI has done. And so there's still a lot of room to improve if you are using an open source model. So that's just my comment on, it's called OPT-IML. So that's the newest open source. If you don't want to use ChatGPT and you want to build your in-house GPT similar to GPT model, then OPT-IML would be the one, probably the best out there. But its performance, I would say, is still 10% or 20 percentage point worse than the ChatGPT. All right. So for next year, my prediction, number one is we are going to see the continuing development in the video generation. Image generation, I think it's pretty much done. The people have done all kinds of image manipulation. So the next real exciting thing is the animation and the movie, the storytelling. You can basically take a one-page script and create a 1 hour movie out of it, right? So that's it. I think that's coming. Probably it will, in 6 months, will be there. The second is production of ChatGPT. We know that people already see Microsoft is putting ChatGPT into internet search. So the Bing, if you use a Bing search, essentially Bing is a competitor of Google, and the Bing is going to incorporate the chat conversational answers to your search result. So that will enhance the make more people to use Bing. Secondly is we can now search for corporate documents like HR documents, your corporate internal memos, your customer data set, all those. So the search that will support the customer support. All the search, because now with conversational understanding, with the embedding, we should be able to quickly deploy the product for the internal search. finally, we are seeing Microsoft is going to incorporate ChatGPT into every product like Outlook, Word, PowerPoint. Meaning, if you are in Word, you can say, if you start, you say, I'm going to write a report for this week. Essentially, you can start give you some very sketchy outline, and then a one-page report will be generated for you. And then you say, if you want to write an email to someone who has been talking to you, then it will generate the email for you. So all this product will be inside the Word. And so you will see a whole suite of a whole suite of product out there. The third thing, what I see and already been developing this year is called the mathematical solution and reasoning. Reasoning means I can give a textbook. I can give a question of chemistry problem, and the program will generate the answer for the chemistry. So basically, it can do all the college exam, right? Physics, chemistry, mathematics. Because now it's able to take any text and do reasoning on that. By end of 2022, we were able to achieve about 50% accuracy. But by end of 2023, what I predict we probably will achieve 70 to 80% or even like surpass human performance. So this, because we have acceleration in terms of the AI development. And finally, the last trend I see as the last frontier is the conversational AI bot. ChatGPT is interesting. It gives you a lot of good results, but it's not purely designed as a conversational bot in terms of taking the context, continuing engage you in conversation and help you solve certain problems until you are happy, you are satisfied. A conversational bot also has to take action, also has to have a memory, long-term memory, also has to do certain things. So there are a lot of application for conversational AI bot. So that's but by 2023, probably this will be very, very mature. So this is what I see will happening. Okay, so now I'm going to open up for discussion. I'm going to allow people, so now you can chat or talk. So any question? I'm trying to rush through to meet our time. Yeah, so you can unmute yourself and
thank you, Jen Lin.
Yeah.
I just had